In our last lecture, we discussed about kinematics, and in that lecture, we discussed how objects move. And in our next lecture, we are discussing about dynamics. Dynamics explains about why objects move, and the reason why objects move were given by Sir Isaac Newton. Sir Isaac Newton was like one of the greatest minds in physics, and he explained so many things. And according to most of the physicists, he was like the most brilliant and most genius person in the history. So he gave 3 laws of motion, and they are also called Newton's laws of motion, and they form the backbone of your whole physics and mechanics. They are only applicable if these laws are only applicable, just like we discussed before in equation of motion. If the speed of, if we are talking about the speed, then it should be really less than speed of light. Like, these laws are not applicable to speed of light. The next thing that you need to keep in mind is that these laws are only applicable to inertial frame of reference. Inertial frame of reference. If it is non-inertial frame of reference, then these laws will not be applicable on them. And these laws are actually empirical laws. You have to know that what are these laws? These are empirical. So these were the conditions that you need to know, that before discussing these laws, the speed should be less than speed of light, like really less, and the frame of reference should be inertial. And then the last thing is that these are actually empirical laws. Like, they don't tell you everything about motions, they are empirical. They tell you about the quality and quantity. We will discuss that in detail in our laws. So first is Newton's first law of motion. So what does Newton's first law tells you? It is telling you that if something is at, for example, if it is at rest, then it will remain at rest, and if an object is moving, then it will keep moving forward unless a force acts on it. Like, if a force acts on the object or on this object, its direction might change and it might start moving. So if it is at rest, then it will remain at rest, and if it is moving, then it will keep moving unless a force acts on it. Like, if the object is moving, then the object stops because the force of friction acts on it. And if an object is at rest, then it will start moving if you push the ball. Otherwise, they will continue what they are doing. So this is called Newton's first law of motion. So the first thing that you need to know about Newton's first law is that it is defining what is a force. So what does Newton's first law is telling you? It defines force. Next thing it does is that it is telling you not the quantity of the force, but the quality. So Newton's first law is qualitative, right? It is not telling you how much force is occurring. It is telling you about what force does and how force acts. The quantitative definition of force would be Newton's second law, but we are discussing Newton's first law. Newton's first law is also called law of inertia, because inertia is the property that is being discussed in Newton's first law. So Newton's first law for inertia is, for example, if you are on a swing, right, or on a ride, and this ride is moving like this, and then it is coming back. So you are sitting on the ride, and the ride is moving forward and then backward. You are really having fun, and when the ride is going forward, your body is pushed backward, and when you are coming backward, your body will be pushed forward. Why is that? This is actually called inertia, because inertia is trying to make your body still. For example, if you are moving, inertia will act in a way that it will say that if you are moving, then you should keep moving, and if you are at rest, then inertia wants you to remain at rest. So inertia actually hates any kind of change in motion. So if you are at rest, then inertia will act in a way so that you don't start moving, and if you are moving, then inertia will act in a way that you keep moving, and even if there is a force that acts on you, then inertia wants you to keep moving. So inertia is opposite to change. Inertia does not want any change in its motion or rest. So the inertia is actually defined by Newton's first law of motion, because as you can see, Newton's first law is saying that an object, if it remains at rest, then it will remain at rest, and if it is moving in a motion, then it will keep moving unless a force acts on it. So this was about Newton's first law of motion. And if we talk about Newton's second law of motion, Newton's second law of motion tell you about what is a force. Force is actually a product of mass and acceleration. So the net force, the total force, can be found by this formula, and this formula is actually telling you how much force is acting. So the Newton's second law actually measures force, like how much force acts on a body. So the Newton's first law defined force, and Newton's second law actually measured force. And Newton's second law is actually quantitative, it is not qualitative. So it tells you about the quantitative nature of force. And if we talk about Newton's second law of motion, then Newton's second law is saying that the formula is F equals to ma. If we can write down F is equal to ma in a different way too. What is the formula for acceleration? As you know that acceleration is rate of change of velocity per unit time. So this is the formula of acceleration. If we use this formula here, then the formula will become F equals to m delta v divided by time. So this is actually the general form of Newton's second law. Like this is in this way Newton's second law also can be written down. So this is the general form of Newton's second law. Like you need to know that this is also Newton's second law's formula, F equals to m delta v over t. That is also the formula for Newton's second law. So this was about Newton's second laws of motion. Let's move towards Newton's third law. Newton's third law is like the most important one, and IMAT mostly asked questions from Newton's third law. First law and second law are good, but Newton's third law is the most important one, and most of the questions are from Newton's third law of motion. So what does Newton's third law tells you? That if there is an action, there is always an opposite reaction. For example, if you are sitting with your friend and you slap your friend, then your friend will slap you back, right? That is action, and your friend gave you a reaction. So according to Newton's third law, to every action there is always a reaction. So the thing that is most critical in Newton's third law is that the action and reaction always acts on a different object. For example, if you say that this is a rocket, right, and this rocket is moving upward, and if you think that if the rocket moved upward and it gave the action, what was the reaction? The reaction was that the gas came out from the downside. So gas gave the reaction. The reaction was not given by the rocket, or you can say that the gas actually did the action. Sorry about that. The gas actually did the action. The gas came out of the rocket and it did the action, and then the rocket started moving upward, and that was the reaction. So gas did the action and the rocket did the reaction. The action and reaction can never be done by the same object. You have to keep in mind that action and reaction are always given by two different objects. You cannot give action and reaction by the same object, and they never cancel out to each other. For example, if you say that if you hit a wall, this is a wall, and the wall will hit you back like this, right? I'm giving you an example, but they would never ever cancel out each other, because they are opposite in direction, right? But they never cancel each other like this. This can never happen. They are opposite, but they don't cancel out each other. Why is that? Because they are acting on different objects. If they act on the same object, then the action and reaction will cancel out each other. That is what I'm trying to say. Like if the action and reaction are given by the same object, then the action and reaction will cancel each other out, and there would be any Newton's third law. So these are the first two conditions, that the action and reaction must be on different objects and they would never ever cancel out each other. So the next thing that you need to keep in mind are other properties. What are that? They are saying that the Newton's third law must always form in pairs. Like the forces should always be in a form of pair. So the first condition is that they should have a pair of force. The next condition is that the origin can be same or different. Like the origin of the forces can be same, and they can also be different. Like they can originate from the same, or just like we discussed about the example of the rocket and the gas, they had different origins. The both forces had the different origins, but they never cancelled each other out, and the action and reaction was given by different objects. The origin of the force could also be same, right? For example, if you are walking on the road like this, if it is you are standing here and you are moving forward. First of all, let me ask you a question. If you are moving forward, is it an action or a reaction? Think about it. If you thought about that, if you are moving forward, then it is an action, then it is wrong. Moving forward is a reaction. What is a action? Like, actually, when you push the ground backward like this is actually the action. When you push the ground backward, this is the action, and in a reaction you will move forward. So moving forward is actually the reaction of how it happened. And the next thing is that the forces are always correct. Like, this law is always correct. It can never ever be wrong. Newton's third law is applicable to all the forces, and it is always given by the same type of forces. You need to know that these forces are always same. The first thing we discussed was that they should have always form pairs, and the next thing is that they should be same force. So both of the forces should always be same. They should always form a pair, and the origin can be same or it can be different, and they should always act on different objects, and they should never cancel each other out. So these are the things that you need to keep in mind while you are solving Newton's laws of motion. And Newton's third law is really important, and these are the things that you need to keep in mind while you are solving these kind of questions. Like, these are the really basic properties that Newton's third law discuss in IMAT exam. So if we talk about free body diagrams, they are not really common because they mostly involve diagrams, and IMAT is not having diagrams anymore, just like in the Cambridge era. After 2023, the diagram questions in physics has been like negligible. There has been no diagram question in physics, so we will still discuss free body diagram. So what is a free body diagram? For example, if you make a box like that, if you make a box like this, and if you think where does the forces are acting, like there could be forces in any direction. There could be a force just like this, right? And there could be a force that is acting like this, right? And there could be a force that is acting like this. So there are three kind of forces that you can see here. This, you can say this is Fx, you can say this is Fy, and you can say this is Fz. So there are three kind of forces that are acting on the box, and when you written down all the forces, then what would be the net force? The net force would be like Fx plus Fy plus Fz. So net force would be the sum of all the forces that you are seeing in front of you. So this is how you can solve free body diagrams. You need to know what are the forces and then combine all the forces, and then you will get the free body diagram solution. So these questions are really easy, to be honest. You don't need to like go into really depth and solve really high and high level MCQs. They are not going to ask you about really complex questions and formulas about 3D diagrams and about how to solve Geometrian examples. They won't ask you really difficult questions. They will simply ask you free body diagrams just like I draw in front of you. The next question is about connecting bodies and systems. For example, if there are two objects, you can say this is object A and this is object B. They were both moving in the forward direction, and the first V1, you can say it is V1 and you can say it is V2. If V1 is greater than V2, what will happen? They will eventually, V1 will reach V2 and they would start moving ahead, combining together like this. And then in this condition, they both bodies connected with each other and they are combined. So you will use the Newton's second laws and all the laws when they are combined together. You will use, for example, F is equal to ma. So how will you use F equals to ma? You will use the mass m1 plus m2 and then you will multiply with acceleration. So that's how you can solve connected bodies and systems. These kind of questions could be different and complex too. We will solve an MCQs. So before solving an MCQs, let's discuss about apparent weight and real weight. Real and apparent weight and the combined body diagrams are really important, and they will be discussed together in that MCQs, so it is better to understand both of these topics. So the example here is that, for example, if you are in an elevator, right, and the elevator might move upward or downward, and then you are holding a spring system, and the spring is holding a mass m, and that there is a tension T. As you can see, this is tension T, and the tension is in the spring, and the weight is W is equal to mg, that is downward because of the gravity. And there are 4 cases that could occur, like the lift might go downward, or it go upward, or it can go in inertial frame of reference, or it can go under a free fall. So let's discuss all these cases one by one. For example, if the lift is in inertial frame of reference, that means that acceleration is 0. What would acceleration would be 0 when the velocity is constant, or you can say change in velocity is 0. When the change in velocity is 0 and the velocity is constant, then the acceleration would be 0. You know that F equals to ma. If F equals to ma and acceleration is 0, then what would be the net force? The net force would be equal to 0. So in this case, the net force equals to 0. And you know that the formula for F equal is tension minus weight. So in this case, the force equals to 0, then what would happen? Then the tension would be equal to weight. So in inertial frame of reference, the tension is equal to the weight of the spring or the mass. So that's what happens in inertial frame of reference. If you are holding the spring in your hand, then the mass and the tension and the weight, both of 3 of these things are happening at the same time. Then if the body is inertial frame of reference, then the tension and the weight would be equal to each other in inertial frame of reference if the lift is moving with constant velocity. If we talk about if the lift is moving upward and it is accelerating upward, then in this case, then the force would be equal to F equals to tension minus weight, right? Tension and weight are in opposite direction. Then the formula would be tension equals to W plus force, or you can say F equals to ma, then the tension would be equal to W plus ma. So both of these equations are correct. So this is the condition when the lift is moving upward. And then if you want to find the tension in the spring, then you will add weight, that is W and ma. You can write it down as mg plus ma or W plus ma, both are correct. I'm writing W plus ma. Okay, this case can also be written down as if the body is accelerating upward. This case is also true if the body is decelerating, if it is decelerating downward. So either the body is accelerating upward or decelerating downward. This case, the formula would be tension equals to weight plus ma. So what if the lift is accelerating downward, or you can say the lift is decelerating. Where would it decelerate? Upward. So this formula would be about if the body is accelerating downward or decelerating upward. What is the formula for force? If the body is accelerating downward, then the formula, what would be the formula? As you can see here, the formula would be weight minus tension, because we are moving downward, and if we are moving downward, then the weight is positive and the tension would be negative. If we are moving downward, then the weight is positive, right? The weight would be positive and the tension would be negative. Then the formula would become, what would be the formula? Formula would be weight minus force, right? You can also write it down as weight minus force, or you can also write it down as tension equals to W minus ma. So this is the formula when the body is accelerating downward, or you can say decelerating upward. So this was the third case. What if the case is free fall? In the fourth case, if you are in the lift and the chain that was holding the lift broke out, and you are now falling under the gravity, you are under a free fall, and during free fall W equals to mg, right? If we follow this formula for free fall, in free fall tension would be equal to W minus mg, because weight would be equal to mg, right? And tension would be mg minus mg. Then in that case the tension would be 0. even if you don't use this formula, like imagine you have a spring in your hand and you are falling under the gravity, then there won't be any tension. The spring will start floating in the air, just like you are in a spaceship, right? The spaceship is actually in a free fall, and in spaceship everything is floating around. Why is that? Because in a spaceship the weight and force cancel each other out and tension becomes zero and everything starts floating. So this was the case for free fall. So these are the four cases that you need to memorize. Like in inertia frame of reference, tension equals to phase weight, and in free fall tension is equals to zero. And if you are accelerating upward or decelerating downward, then the formula would be tension equals to weight plus ma. And if you are accelerating downward or decelerating upward, then the formula would be tension equals to weight minus ma. So these were all the important formulas that you need to memorize if you are solving these kind of MCQs. So let's discuss about our MCQs that we were going to solve here. So the MCQs is saying that you have a 3 kg block. You can say this is M1 and it is on a frictionless table. Like this is the table. Let me draw the table for you. Like imagine this is a table and you have a mass that is present on this table. Let's draw the mass or block, and the block is M1 and it is connected with a mass M2 that is floating down like this, M2. It is both of these are connected with a pulley, and the mass 2 is hanging, and the mass 2 is actually 2 kg. So they are saying that what is the acceleration of the system. So acceleration of the complete system, not acceleration of M1 or M2, but acceleration of the complete system, and the tension in the string. And they are talking about the tension that is in the string, that is T. You have to find two things. First is acceleration and then is tension. Let's talk about first about the acceleration. You know that if you want to find the acceleration of the whole system, then you need to find what is the force, total force, and you need to know about the total mass. So formula for acceleration equals to F over m, that is from F equals to ma. What is the total force? To find the total force, you will need to find the force that is equal to F net is equal to m2 multiplied by g. Why we used m2 not m1? Because the force is because of m2. m2 is the one that is pulling downward, not m1. m2 is pulling under the gravity. That's why the force is because of m2. We used mass 2 and the gravity g. The total force that we got was 19.62. So the force is actually approximately equals to 20 divided by what is the mass. We have to use total mass because we have to find the acceleration of the whole system. Then the mass is 3 plus 2, that would be 5. So you will get the answer for acceleration that is approximately equal to 4 meter per second square. They solved and they got the answer 3.92. So 3.92 is really close to 4 meter per second. We used the answer in approximation. We were not solving the points, we solved the whole equation, and then we know that the closest answer to the 4 is 3.92. That's how you will be solving physics questions in your IMAT exam. You don't have to solve decimal in your IMAT exam, because if you solve decimals then it will take a lot of time. So first what you need to do is that you should neglect solving decimals and solve the question without the decimals, and when you get the answer, then the closest decimal to your answer would be the correct option. If the answer is, for example, if the answer options are 3.96, 3.94, then obviously you would have to solve the question in decimal. But if the options are 2.92, 4.92, 5.92, then you can solve the question in approximation and you will get the answer 4, and the closest would be 3.9. What about the tension in the string? As you can see, the mass is moving downward. We just discussed the formula for motion that was accelerating downward. What is the formula for accelerating downward? That is tension equals to weight minus ma. When you use the formula, that is tension equals to weight minus ma, right? What would be the formula? The formula would be mg minus m. You can also write it down as mg minus ma. M would be common. You will get tension equals to m. You will get g minus a. What is the mass that is common in both of them? That is m2, because the motion is because of m2. So the mass you will use here would be m2, and as you can see, this question is solved here. The mass is 2 kg, the gravity is, you can use 10, acceleration is 4, 10 minus 4 would be 6, 6 multiplied by 2 would be 12, and the answer that is closest to 12, that is 11.8 Newton. So this is how you can solve physics questions in your IMAT exam. These questions might look really difficult right now, but believe me, as you practice more, as you use these shortcut formulas that I'm giving you in these lectures, these shortcut formulas will help you out a lot in your IMAT exams. Like these shortcut formulas are like the gold mines. Like they will give you a really big edge on all the competition towards all the students that are attempting IMAT. If you use these shortcut formulas, then you will solve the questions in a jiffy, like in a few minutes, while other students will think about what is tension, what is force, what kind of formula could be formed. You have already formed formulas in your hand, you have already memorized these formulas, you already have all the shortcuts that are already in your hands. You just have to put the options, you only have to use the question and the formula, and answer would be in front of you. So I am telling you, the physics has been made really easy for you by these lectures, because shortcut formulas will help you solving physics MCQs a lot. Next thing is that we will discuss some more shortcut formulas. So these shortcut formulas will also help you out a lot. So if there is a question about, for example, if an object is moving and the object took like 15 minutes, and during those 15 minutes there was 1 kilometer distance that it covered. What was the distance that it covered during the 50th minute? And you will be like, how to find this kind of a distance, like what happened on the 50th minute? If you traveled for 20 minutes, then how much you traveled at the 10th minute? You know, that seemed really weird, but there is a shortcut formula that you can use to solve these kind of MCQs. So the formula is S nth. Nth is like 20th minute, 20th second, 30th second, and on the nth time the distance would be equal to initial velocity plus g by 2, or you can say a by 2. Sorry about that, we are talking about linear motion, we are not talking about a drop object yet. In the linear motion, the acceleration is a divided by 2, and then you will use 2n minus 1. So this is the formula that you will use in linear motion. This is the same formula that will be used in the dropped object, but it will change a bit. S nth equals to Vi. As you know that when you drop an object, if this is an object and you drop it, the initial velocity equals to 0, right? Vf is not equals to 0, but initial velocity equals to 0. Then that means the initial velocity would be 0. And when an object is moving up and down when it is dropped, then the acceleration is actually gravitational acceleration. Then you will write as gravitational acceleration divided by 2 and 2n minus 1. So this is the formula. If you want to find the distance at nth time, nth second, nth minute, or nth hour, for example 4th second, or you can say if you dropped an object, what is the distance that was covered at 30th second, then you can use this formula to find the distance. Let's discuss some more drop cases here. For example, if you get a drop case, then initial velocity is equal to 0 and a is equal to g. What could first equation of motion will become? What is first equation of motion? First equation of motion is equal to Vf is equal to Vi plus Gt, right? As you can see here, initial velocity is 0. So what would be? It will get only Vf equals to Gt. So this is the first equation of motion for the drop case. As you can see, let's just talk about second equation of motion, that is S is equal to Vit plus half At square. And in the drop case, the distance is actually height, so S would be removed, and in the drop case the initial velocity equals to 0, so Vit would be 0. And as you know that the acceleration is actually gravitational acceleration, then A would be g. So the whole equation would be written down as h equals to half gt square. Vit would be removed. So let's write it down again. Second equation would become h equals to Vit is equals to 0. You will get half half gt square. So this would be the second equation of motion. Let's talk about third equation of motion. What is third equation of motion? Third equation of motion is Vf equal to Vf square, or you can say equals to 2gh minus Vi square. You know that Vi square would become 0 because initial velocity is 0. You will get Vf square equals to 2gh, or you can say Vf equals to, taking under root on both sides, you will get under root 2gh, and taking square root on this side too, the square root and square would cancel out each other, and you will get Vf equals to 2gh. So these are the formulas that are used in drop case. This is first equation, this is second equation, and this is the third equation. So this is how equations would be converted in the drop case. That would become Vf equals to 2gh, h equals to half gt square. There are other ways that you can write it down. You can make it more short. You can write down it as, what is g? G equals to 10. So Vf would be equals to 10t. G actually is 9.8, but why I am writing 10? Because you will find the answer in approximation, because multiplying with 9.8 is difficult, but multiplying with 10 is easier. So the answer would be really close to the real answer. If we use this formula, you can write it down as h equals to, what is g? G is 10 divided by 2, it will become 5t square. So this is also how you can write these formulas in a more shortcut way. So V is equal to 10t, h equals to 5t square, and Vf would be under root 2gh. So these are the equations of motion that could be used in the drop case. Let's discuss these formulas in our equations. For example, if you have dropped an object like this is object and you dropped it, and what is the distance or velocity and height that is during the first second, right? 1 second, 2 second, and 3 second. So during these seconds you will need to find velocity and height. So first thing that you need to know about is velocity. During the first second, what will be the velocity? You know that formula is Vf equals to gt. So this is the 1 second, then 2 second, and 3 second. The first second, the velocity is equals to Vf equal to gt. What is g? G is 10, and what is t? It is 1 second. Then the velocity would be 10. What would be the velocity as second? It would be 20, and at the 3 second it would be 30. So this is the velocity that you can find out using the formula Vf is equal to gt. If you want to find the height would be equals to 5t square, right? So first thing that you need to know about is there are different kind of formulas for during and after the seconds. So if the ball has fallen for 1 second, then this is the distance after 1 second. Then it will cover the second distance, then it would be after the 2 seconds. Then it covered 3 seconds, then that would be after 3 seconds. But if they ask you about what is the distance that is covered during the third second, then that means they are talking about only the third second. And if they talk about after 3 seconds, then that means they are talking about the whole distance that it covered during first 3 seconds, and that the formula would be equal to 5t square. That is the formula for after the 3 seconds. If you are talking about during, then the formula for during we have written down at s nth equals to g by 2 2n minus 1. You can make the formula more shorter here. You can write it down as g by 2. What is g by 2? G by 10 by 2 would be 5, right? And the formula would be 2n minus 1. What is 5 multiplied by 2? That is 10n minus 5. So this formula can be more short, as you can see here. So I will write down the formula here, that is 10n minus 5. The formula for during the motion is 10n minus 5. So these are the formulas for during and after the first second and third second. So these formulas could be used in your IMAT exam, and these are the shortcuts that are really useful in solving these kind of MCQs. So if we talk about the first second, if it is about after first second, the after first second formula is h equals to 5t square. So what would be the answer? The answer would be h equals to 5t square. T square is 1, t multiplied by 5, it would be 5. If we talk about the second, the formula would be 2 square. 2 square is 4. 4 multiplied by 5, it would be 20. And if we talk about after the third second, the formula would be h equal to 5t square. 3 square is 9. 9 multiplied by 5, it would be 45. So this was about the after the third second. What if we talk about during the first second, third second and second second? During, the formula is 10n minus 5. So let's write down the formula for the during situation. So the formula for during situation would be during, the height would be simply 10n minus 5. What is n? N is the first second. 10 multiplied by 1 minus 5, it would be 5. So if the distance covered during the free fall is 1, 2 and 3, so this is the distance during and after, because only 1 second has passed, so during and after would be same. If we talk about the second second, during the second second, the formula would be 10n. 10 multiplied by 2, it would be 20. 20 minus 5, it would be 15. So the distance covered during the second second is going to be 15. And if we talk about the third second, during the third second, the formula would be 10 multiplied by 3. 30 minus 5, it would be 25. So as you can see, the formula for during and after is really different. If we add all the seconds, for example, if you add 25 plus 20, 15, it would be 40. 40 plus 5 would be 45. So the total distance after 3 seconds would be the sum of distance that was covered during first second, second second and third second. So as you can see, these formulas are really useful during the first second, during second second and during third second, or after the third second. So these are the formulas that you could be used as shortcut to solve these kind of MCQs. I hope you have understood these formulas and how to use them in your IMAT exam. We discussed at least so many MCQs. In this box there were like 1, 2, 3, 4, 5, 6, 7, 8, 9 MCQs were discussed in this box, and then we discussed about like 6 MCQs in the drop case, and then we discussed 1 MCQs here, and in this 1 MCQs we discussed 2 concepts, and then in this table we discussed about 4 MCQs in real and apparent weight. If we talk about free fall, there was one thing that we left here. In free fall, you can see here the tension equals to 0. So in this case, what is the real weight and what is the apparent weight? This is the question that I'm asking from you. You can think for our time. The answer is simple. The answer is that the real weight is not equal to 0, but apparent weight is 0. In this case, the apparent weight is 0, not the real weight. For example, if you are in a free fall, does that mean like all your belly fat has been gone, or suddenly you became slim? No, the apparent weight became 0. The weight that was pushing you towards the gravity became 0, not the actual weight. So the actual or the real weight is not 0 in this case. The weight that is 0 is actually the apparent weight, the weight that was pulling you downward because the gravity became 0, but the real weight remained the same. So this was the MCQs that can be appeared in your IMAT exam. We discussed about Newton's laws, and this chapter about dynamics is done. So these MCQs were really important. So I hope you find these lectures helpful, and keep solving all the MCQs that you can get from these topics. IMAT physics is all about practice. If you are not practicing enough, then you will get really hard times in solving these MCQs in real exam. So I really recommend solving the mock exams that we are giving to you, because those mock exams are exactly like the IMAT that is going on from these years. Don't use old past papers, don't use old practice material like Ultimate, IMAT guide or BMAT past papers. They are not relevant to your IMAT exam anymore. No doubt they have the same syllabus, you can still practice them if you want to clear out your concepts, but they are not relevant to your IMAT. The reason is because the IMAT pattern has changed. The syllabus is the same, but pattern has changed. If you want to solve BMAT or old IMAT past papers, then it is a really good thing, but you need to solve the relevant and the exact pattern that is going on right now first. If you are done with IMAT Sensei past papers, if you are done with IMAT Sensei mock exams, if you are done with our tests, and now you have free time, then go and solve out the BMAT past papers, IMAT past papers after before 2023 past papers. Then it is a really good thing to do. I really encourage those students that are solving those kind of questions, but don't solve those questions if you are not done with the current paper pattern, because the IMAT exam is going to be the really relevant to IMAT Sensei MCQs that we are providing to all of you. So solve all those MCQs, practice them as much as you can, and after you are done with those MCQs, then you can switch to other type of MCQs that might appear. So this was all from my side. I hope the lecture was helpful. So bye bye, take care.